Hi there, my name is Rick Butts. In this video, I'm going to show you how to import controls into the controls branch of the program. As each control is imported, you can create cables, work on your cable schedules, just like motors. This is actually a continuation of the motor import videos, really focused on controls. So let's get to it. Okay, here we are. We're using the same demo project that we used to import motors for. That was the previous project, so we're going to use that same one. As you can see, we've got do a right click here and expand all branches. So we've got our MCC1, MCC2. We've got all our P cables, which were created on that project. So now what we're going to do is we're going to build on this to demonstrate how to import controls. All right, that would be the next step down, import controls, and it's going to be via spreadsheet as well, and I will show you that in just a minute. But before we do that, we have to give ourselves some control power. So we're going to run our utility or lighting power panel out of MCC1. We could add a breaker to MSG, however we wanted to do it, but let's just go ahead and say what we need first of all is a circuit breaker, and let's add it to MCC1, and we will say a new branch, and then we're just going to call this CB B, and then this is going to be CPT. So this is our control power transformer, and it's going to be a 2-pole. We're going to do a single phase. And let's go BC, and we'll just start with a 15 amp breaker, and let's go. So that adds our breaker. Then we're going to take a transformer and connect it to that breaker just like you would do, and this is going to be, we'll call this CPT, and this is control power trans. Same deal. It's going to be attributes. So we want winding material, aluminum, options. We don't need any of those. Accessories, we don't need that. Listing, go UL, enclosure. This is going to be pole mount, pad mount, NEMA 1. Basically be NEMA 1 dry type. Okay, there you go. So there's all our attributes for that. And we're just going to be BC. It's going to be 240.13. We're going to feed it to a little distribution panel. And let's give it, I don't know, 10 kVA. Okay, so basically there's your primary FLA. Primary FLA times 1.25, and then your secondary FLA, and away you go. So max is the 60 on the secondary, max circuit breaker, max fuses there, depending on your size, things of that nature. All these rules come out of the NEC, and we're going to do there will be a cable for that, and it'll be sitting right next to the MCC. So let's just do let's just do liquid tight flexible metallic. We'll deal with, so we ended up with multi was our last cable that we did for P cables. So let's go back to single and THHN, and it's going to be all number 10s, 3 number 10s, and our fill percentage is 40%. So I've got a minimum size set at 3/4. So there you go. So there's your, and you can see that there's your P cable that feeds your CPT right there. Now we're going to go ahead and say, you know what, we need a little distribution panel. Let's tie that to here. And it's going to be 10 feet away, less than 10 feet away, but it's going to be within a raceway. And really these are just, those are your tap conditions, which dictate the minimum size of breaker or protective device that you can have. So in this case, we have a secondary FLA times 1.25 is 52 amps, and the next size up is 60. So it sized that for us. We're going to go with a main device, which is a circuit breaker. You could do attributes for that circuit breaker, but there's your main device for your distribution panel. And you'll notice on the distribution panel, this is a otherwise referred to as a panel board. It only has a main device as a circuit breaker as possibilities. We do not need 42, and just for make it easy from a size standpoint, let's just give it 20. Now And we could call this LP1. Okay, this is now something I want you to show. Typically, this is a 52 as your max, and really, to be conservative, you would not really want to run a 60. You would run a 50 as your main, not a 60. So 50 would actually be considered some sort of a this sets you up, since you connected a distribution panel directly to the transformer. It sizes the breaker as the next size larger than your max secondary FLA times 1.25. But we really want it to be 50. So that technically is going to be a tap where you're doing some percentage less than full load. So this is what you would run if it was full load. So let's just cancel out of this. And what we're going to do is we're going to go down here. We're going to take a tap and we're going to put it on this CPT, and these come up as load lugs. So what we're going to do is we're going to tap off of the transformer secondary load terminals, and we are allowed to, the full size is 60 amps. We're allowed a maximum of 6 taps. We really only want one, and it's going to be 50 amps. But technically, you would have 10 amps of capacity left for this transformer. So let's say, okay, so that sets up our, and we have load lugs. Now we're in a position to do a tap that's less than a full load. So go back down and add our distribution panels. Okay, and still 10 foot. Okay, but you could see you could go down as close to 10%. So 10% of the 60 is 6, but we want to actually just select 50. Okay, which is really probably the right number for that transformer. So let's just do LP. So there's your breaker, and we need about let's go 20 breakers. We'll do 10 on each side. 2 pole on your main, it's 240, 1.3, so it's with a neutral. There you go. Okay, and it'll do the cable for that. Again, it'll be single conductor. Single conductor. We're going to run it in a. Now, in this case, you're going to be doing a L cable. L cables, P cables are 241 to 600 volts. L cables are 0 or lower voltages, generally around 24, whatever you want to run, depending on the secondary of your transformer, but low voltage up to 240 volts. And since this is 240 volts, you're now creating an L cable. And then everything that feeds out of this distribution panel will be an L cable. So this is the first time up. So let's select HWC. We're going to use the same type of wire. Okay, and it's going to be in a raceway. We're not going to have a cable tray. And you'll notice this time that since it's less than 100 amps and it's not a motor circuit, that it's going off of your 60C column rather than your 75C column. It's a non-motor circuit type, so it's calculating out of C1 rather than out of C2, which you would do if it was a motor. And it gives you basically, it will be, you'll have 2 phase conductors that are number 6. You're going to do a full neutral, number 6, and then it'd be a number 10 ground. So there's your, so you basically have in this case, you're all set. We could do RMC. This may also be liquid tight since it's right. We're going to do the panel board right next to the transformer, so it's inside the MCC room, so it's 86 degrees, and away you go. So there's your cable for that. Neutral spec same as the phase, ground spec same as the phase. So now you have a distribution panel here. And all of this I'm doing because I gotta have some small breakers. Okay, we're gonna do the left side. You get the left side and the right side. So here we now have an LP lighting panel. You could do UP for utility panel, whatever you wanted to do, because this is your 240 volt distribution panel. We need some 120 volt power to feed our PLCs and to feed our remote IO cabinets and things like that, to allow us to import controls. This is all set up to allow us to import controls. So one of the features that I've given you is you could have 42 circuits on each, or excuse me, you could have 27 on each side or 26 on each side for a total of 42. So I've given you the ability to just take a protective device, can only be a circuit breaker in a distribution panel. If you want to do a fuse disconnect switch, you'd have to drop them into either a switchboard or a main switch gear or an MCC itself. So we're going to create a 20 amp breaker in space 1. Okay, and these for distribution panels are all numbered 1 through whatever on that side. For the left side, it would be odd numbers. For the right side, it would be even numbers, and that pretty much matches existing convention. So rather than giving your circuit breaker for a distribution panel a number, we actually just assign it a number. It's going into space 1, so it's going to be CB01. So basically, we're just going to pick a 20 amp breaker, okay, for the this is going to feed our PLC panel. All right. Now, the nice thing I've given you here, because since you got to do a bunch of these things, and you can do attributes for this circuit breaker if you want a ground fault or some sort of shunt trip or something like that, and you wanted to copy that to a bunch of them. So I'm right-click copying this device, and I am putting it down here, and I'm going to populate this entire left side with 20 amp breakers. So I'm doing right-click again, and I'm going to paste device. And see, so what it's got is this time it's CB03, same setting. CB04, CB05, 7, 11, 13, 15, 17, and 19. If you were doing 2-pole breakers, if you're dropping 2-pole, and that's the most you can drop into a 240/120 panel, it would take 2 spaces at a time, and you would be missing. So let's just do that. Say we got some 30 amp 2-pole heat trace or something we want to run out of this. So let's do protective device, circuit breaker. Okay, this is going to be CP02, and this is going to be a 2-pole. And since you have a neutral in the panel, you have a neutral available at the breaker, but you don't necessarily have to run a neutral wire. That depends on your actual load itself. So let's make these 30s. So now we have a bunch of 30 amp 2-pole breakers. All right, so I'm going to copy the first one in there, and you notice it consumed space 2 and 4. So now I'm going to copy this to all of these. And that's a shift select that selects them all. Very similar to you're familiar with the Windows. Control will do one at a time. Shift select selects a whole range. So now I'm going to do paste, and it'll go 6, 10, 14, and 18. So you basically got 10 single pole breakers up here. We just put in 2-pole breakers here, so you got only 5 of those. So that makes it real easy to populate these distribution panels, which could have a ton of breakers. Right now, we do not have the capability to subfeed to another distribution panel, but I'll be adding that functionality. Right now, we're limited to the single distribution panel. So we've got a bunch of 20 amp breakers, and what I want to do is for controls, very similar to the way when you import controls, you have to have a place to start. You got to have a from for your first control device. So you need to create, so since there's nothing in controls, you got to create something to start the tree, if you will. So what we do is basically when you drag a control in there, you have a from and a to, and you're defining the cable that goes between those two. In this case, what we're going to do is we're going to start at a PLC panel. So let's go ahead and take one of our loads, and we're going to just go down here to a control panel, and we're going to drop that on our first 20 amp breaker. And we're going to label this PLC. Okay, this is our main PLC panel. And let's give it a size. Let's just say it's 700. So this is 0.75 because this is kVA amount. So we're just going to say 750 VA. So there you go. And you can see your minimum circuit size is 750 VA divided by 120 times 1.25. Connected is 6.3 amps, and your minimum circuit size is 7.8. and you'll know if these are continuous loads. If you had non-continuous loads, you could enter them here. If it was three-phase, or you want to calculate what a single-phase motor is and put this in here, you can do that as well. So if you had other things for standard attributes, manufacturer part number. So we're going to create a cable for that. All right. Now here you go. Now the thing about these are branch circuits, so the size of the load does not dictate the branch circuit size. The actual breaker itself dictates the branch circuit size. That's why you have 20 amps as your circuit size rather than, I believe it was a 7.3, which is what the panel required. So in this case, everything tied downstream of that 20 amp circuit breaker has to have a circuit size of 20 amps, and it's going according to the 60-degree C column because it's a non-motor, and then because it's less than 100 amps. Once you get to continuous loads that are above 100 amps, then this will convert to 75, all dependent on the termination temperature rating. And so you got 3 single conductors here, and away you go. Let's just, this can be in the field, so let's just run. We may down the road run through cable tray, so let's just run a 3 conductor. This is pick our, not metallic, let's pick 3 conductor, and then we want to go with the tray cable exposed routing, same rating as our power cables, and it's still 600 volt insulation, so we could put this power cable, L cable, in the same control power cable tray as our P cables because they're all 600 volt insulation. So there you go, we've selected that. We're down to 3 conductor number 12. So you got one cable like it's always been, so you can go with 53%. We're at 24, so we're okay. We're gonna stay, and let's go to RMC. Okay, so there you go. And it's in the field, so let's increase the temperature of the wire, derate it according to the ambient temperature, and away you go. So there you go. All right. So now we have created a PLC device. All right. And what we're going to do is we are going to run power to some of our, we will have remote IO panels, we will have field devices. We combined all of that power requirement in that 0.75 or kVA or 750 VA load of the PLC panel. So we're going to run L cables in the control to the controls, but that they do not, controls that are inserted down here in the controls branch do not add to the load of the system. They are covered by the load that was all added right here. So now we have our anchor for our control system, and I'll show you why that's important here in just a second. So we're going to go and we are going to import controls. All right. So now let's go back to our subdirectory, import exports. And you remember we had a project motors we went through just in the past video. This time we have a project controls. All right. And in this case, it's very similar that you got your rules up here. You got it. In this case, you have a device type that you have to tell what kind of control device it is. And you see, I don't think, okay, here's where your device types are. You go up here and you do controls. These are all your device types. So it has to be one of these device types here, all right? So let's go back over to, so there's your device type. So it can be an RIO panel, it could be an HMI, it could be a net panel. These are net devices. Just a typical panel, you can use it for anything you want. You've got the ability to put comment lines in here, and this is pretty much, these comment lines are the same for the motor list. Annunciator devices, which are horns and lights. You got control stations, which are button stations. It could be e-stops or multi push button stations. So these work very similar in that, let me move this thing that I can't see. I can't move it. you have to start from your PLC. So these devices, when we insert a control, we are going to be the from for each one of these devices right here is going to be PLC. These devices here, there will be the from will be RIO1. These devices here would be the from would be RIO2, and then these would be the control device ID tags. Then you got TB101, TB102. So these tabs are the from devices for your control. So you use PLC, and what you're going to notice is we are going to create RIO1 in this tab, and then RIO1 and RIO2 will become froms on these tags. But since they will exist already because they will be created here, then when you look for RIO1, it's going to be, it either has to exist in the power or it has to exist in the controls table. So either one of those tables you can run things to. So you could actually have an MCC1 or MCC2 down here and run devices directly from that. But that's the way it works. This is your anchor. These become your froms. Then your froms need to be created and available so that when it goes and looks for them, it finds them. And basically this is kind of the way it's done. So you could have a series of panels, whatever. So we're going to go ahead and let's just file save as. Here we go. And we're going to call this PLC IO, just to differentiate it from the template. All right, so there it is. So there's your PLC IO, and here we go back over here to create. We're going to utilities, import controls, and we're going to select right here. A file is in use. I didn't close it. Okay, it is closed. And here, this is kind of a typical form for all your control devices. And you can tell it where to go find this device if you want to. We're basically looking at the power tables, and it is a CP device and ID tag PLC. So it has found a PLC ID tag, and it has created that as from, because that's the tab name for that first sheet. And then we're going to start creating our remote IO panels. Now, in this case, we're going to run our power, which is 240 or less, from the PLC to the RIO. So we're going to create an L cable. Turns out we also need an E-stop cable, so we're going to need a control cable. We do not need a signal cable. There's no signals going from here to here, but we do need communications cables. So there you go. So we're going to create this, and when you press save, it will then bring up each one of those cables. This is your L cable form, but these are the manual forms. These are not the automatic. So there is no sizing related to this cable. Because the cables you do for control devices, those control devices do not add power to the power branch. So we're just sizing it manually, and we're just going to run one. We know we got to run, well, it depends on, let's just say we have 15 amp circuit breakers in PLC, and we're running from those 15 amp circuit breakers, it would be number 14. If you had 10 amp circuit breakers and they were rated for number 16 wires, then you could collect, you'd have to go to another wire type over here, but then you could select 16s if it was available. We got neutrals, so let's do ground. Ground is HWC. It's going to be, we don't want bare, we want insulated. HWC, THHN. Okay, so there's your ground cable, and then your neutral specs is insulated HWC, THHN. Now this should come up. It should remember that. It does not remember it right now, so I'll show you the next time around, but we're correcting that. So it doesn't remember the ground specs and the neutral specs for the next L cable. So basically you are now running one parallel run of number 14, three number 14s, one phase, one neutral, and one ground. And we will put it in, we'll just say an RMC or in the field. So you don't do any temperature, ambient temperature compensation, but you do select the wire size, stranding, manufacturer, and all these different requirements for your, we have a limit. I'll show you, there's a settings over on the file menu where you can do minimum conduit sizes based on what your installation requirements are. Right now we're on, for an RMC, we are a minimum 3/4 inch. So we got plenty of room left over. We're gonna press save. So that was our L cable running from PLC to RIO1. Now this is our control cable, and let's just go with HWC, THH, what else do we got here? Oh, we got to do multi. So we don't want single conductor. We want a multi-conductor. Okay. So there you go. We got HWC TFFN, number 16, 3 conductor, but this is going to be a e-stop circuit. So let's run number 7 conductors and 40% fill. There you go. So now you've created your control cable, and that cable goes from, again, it goes from PLC to RIO1. And now we need we want to go with 4-pair 5E. We need 2 Ethernet wires. And here you go. So we're going to do 2 of them and whatever color you want. Let's do blue. And these are actual E cables. Okay, I'm going to press save here. Okay. And now, so now you go into the next one. And so basically now you got RIO2. Yep, we want to, same deal. These are going to be duplicates. Save. And this is pretty much our last L cable. You can see we didn't remember our neutral or our ground specs, but we're just going to say, okay. We'll get that fixed next time around. And as you can see, and then here's our control cable, which is still multi-conductor. This is to, oh yeah, this is controlled cable to RIO2, so it's going to be a 7-conductor. This is our e-stop circuit. So that's that. And then PLC to RIO2. Here's our Ethernet. We want 2 blue Cat5Es. There you go. Okay, and now we're on to from PLC to our OIT, which is the process touchscreen operator panel. In this case, I guess we pretty much need the same thing. We need power from the PLC, and we need a control because there's going to be an e-stop button, and we need an Ethernet. So pretty much the same as the 2 RIO cabinets. And so there's our L cable for that. And there's our control cable, still 7 conductors. And this is OIT. For Ethernet cables. There's our 2 Ethernet cables. One's a spare. And now we're going to our network panel, which is, let's just say this network panel exists and is already powered up, but we got to run a bunch of Ethernet cables from the PLC to this could be the plant floor network switch cabinet that's already powered, already hooked up and installed. So let's just note that. All right, press save. And in this case, for whatever reason, we need 4 Ethernet cables running from the PLC cabinet to the network cabinet. Okay, and here's our just a display, efficiency display. So we just need power. Again, all these L cables are coming from the PLC cabinet, and so the loads for each one of these devices is already included in that load for the PLC cabinet. So same deal, we need 3 conductor for 14s. For power, going to the efficiency panel, and we don't need a spare Ethernet. This is just going to be a wall monitor. We're just going to do 1. Okay. And then we've got alarm horn, which we just need a control for. And the smallest number for TCER is multi-conductor. I believe it's 3. Yep. So we're going to run. We do not have a 2 available. We'll get into how you determine what capabilities, what wires you have available. That's in user data, and that can be changed or added or deleted. You could use whatever manufacturer you wanted. For these selections, I've just thrown in some data so that we can test the system. Okay, so there's all you did was a control cable, same deal with a horn. All we need is a control. If you had some special kind of horn that needed a, communications or power or controls, whatever, you obviously can add them. Okay, going with 3 conductor 16 because that's the minimum we can do. Press save. And I'm just going to go through these real quick. These are all still coming from PLC. Okay, so that was the first page of the list. Okay, and 3 conductors, saves. PLC ES2 controls. ES are actually, let's just do 5 conductor for ES buttons, E-stop buttons. Terminal block. Now you see, now our from becomes RIO1. See, we have created RIO1 in our, and that's just something you can do if you want to, if you're like in the middle of it and you want to get out of wherever you're at. Just do cancel, cancel. If you cancel 3 times, it'll say, are you sure? I guess you want to get out of the import process. So let's say yes and see where we're at. Okay, so basically it just ignores everything else. We're going to go back in and let's look at our controls. So here's what we did. These branch headers here are the type. These are the device type. So we have created 2 remote IO cabinets. We didn't create a PLC, remember, that's down here in our distribution panel. So there's our PLC. But we did create 2 remote IOs, 1 OIT, 1 net panel, in our registry of control devices. We have 2 control stations, which happen to be e-stop buttons, 2 annunciators, which are alarm horns, 1 just generic panel. So these all have, if you look at these now, these are our control device schedules, and they are all coming. Let me see what we got here. Here's our from. See, these are all from device is a CP2 device, ID tag. There's your ID tag, and there's your 2 device, okay? And then there's your descriptions right there, okay? And then I'll show you, we actually are able to break it up into 3. If you want to make name tags and stuff, I've got a utility up here that says 3-line descriptions. You can actually break real easily, go through all these and break them into 3, then print that out or export that to make your name tags. So we've got that. So there's that. Now what we've also got, so now let's get back to where we were and say import controls, and what it will do is it'll just ignore all those we've already got. Okay, control RIO already exists in the project. Skipping this control, yep, that's the one we've already created. I think we're gonna have to, yep, 302, 1, net 902. These are all the devices we've already created. Okay, now we're back to RIO1 and we've got these other TBs. So what I'm going to do is, let's just say this terminal box, we're going to run signals and controls to it. So we need 2. We need 1 of each. So we're going to do 19 conductor controls. We're going to stay with number 16, and that's a 1-inch RMC. Okay, signals are your shielded. By and large, they are going to be your shielded cables. Okay, so let's just do 12 triads. You can, depends on what you select. This control and signal database of cables can get real confusing because Belden doesn't just use copper, it uses bare copper, it uses tin copper. You got to kind of know what's in your database to select what you want, because if you go to like tin copper, then you get pairs, 1 pair or 1 triad. If you've got bare copper, then you got 1 pair and that's it. Then if you go, I think we got let's go just copper. And you got Belden, let's go HWC. Now you've got, actually, rather than triad, you've got, so let's just do triads and pairs. So you pick what you want. So let's just do 12 pairs. All right. And you can see RMC, away you go. Okay. So I wanted to show you that signal cable, and it's going to come back TB102. It's going to be the same as it was. And you got 19 conductor for controls, and you got 12 pair for your signal wire. So that is running from RIO1 to TB102, okay? Now what I'm going to do is I'm going to just pause here. You don't have to watch me, but now I'm going to go ahead and import all the rest of those devices. You got a solenoid, so it's just going to be a 3 conductor, and then I'm going to create them all, and I'm going to show you all those cables. So we're real close to the end, so let me just pause this here, go ahead and import all the rest of these control devices, and then we will go from there. Now you can see I've control import is complete. Let's see what we got here. Press OK. And you can see we've got all these different devices, the safety devices, transmitters, controllers, elements, sensor elements, switches. YV is solenoids or actuators, TBXs or terminal boxes, control stations, annunciators, panels. So you can see, and it took, I don't know, another 15, 20 minutes, but we have basically now completed our entire cable schedule for power 480 for L cables. Let's just go to our cable schedule here, right? And you can see what you've got. There's your cable tag. Basically how you got parallel runs shown. You got lengths here. Each one of those forms had a length that you could have filled in, but I've got a real easy way of going through it real quickly here, and I'll show you that utility for cable lengths here very shortly. So all your sizes, is it a single conductor cable? You can see single conductors have ground sizes. If you got 3 conductor, which would be a multi-conductor, they don't have grounds or neutrals. Here's your single conductors, 3 conductors. You can basically, you got S cables, you got E cables, which are your communications. S's are your shielding cables. Signal wires, controls are your multi-conductor cables, number 16s, 14s, 18s, whatever. Then you got L cables, which are your 0 to 240 volt power cables. Then you got P cables, which are your 480. And then if you had a system with medium voltage 4160 volt motors or anything like that, you could have those cables would be in here. And so you basically have your entire cable schedule right here. You can see that. You can print it out. You can export it as to spreadsheets. But there's a lot of different ways. One thing we're going to be, you want to look at the actual dimensions. This is more for testing, but it tells you what your square area is. This is all used in calculating the fills and stuff like that. And then you got feet per pounds per 1,000 feet, stuff like that. So there's all some sizing dimensional information for your cables. Your raceways here, we have not created any raceways. We're going to do that next. But if it's a cable tag, you will have a cable tag listed here. If the cable is capable of running, if it's rated for a tray and you have assigned it to a tray, that cable tray will be here. And then your conduit systems that it runs through are listed here. And we will go through that in future videos. But let's go down here and look at bill of materials. Now you got multi-conductor cables. Yeah, basically you want to just look at what types of cables. Here are the cables that you've specified. You got 300 volt cables for your signal wiring. You got 600 volt cables for your controls and power. These are PLTCs. There's Cat 5e. So these would have to be run in a control, the low voltage control tray, an instrument tray. All your TCERs could go into a control and signal tray itself. You got, and a little bit of specifications of what it is. This is, again, this is multi-conductor. And if there were total lengths, if we had put any lengths in here, they would show up here. You can look at single conductors. So you have number 14s, you got, I guess we missed one. We got RHH We got THHN most of the time. That's what we were trying to use. This is where it didn't reset the ground and the neutral for us. But you got part numbers, manufacturers, you got distance for phase, neutral, and ground if you wanted to get a green and a white wire. But all your different sizes are shown there, and you would, again, your feet would be set. Your distances would be set had you put that number in there. Power devices, let's look at what we've got. We got a distribution panel. We have one distribution panel. It's 60 amps. We have a control panel, which is 0 amps. This is our PLC. We got a bunch of circuit breakers. We've got one, two, three, four. You got a 250 horsepower motor. You got a 200. You got a source. You got a tap. This is the connection off the CPT secondary lugs. You have one dry type transformer. Control devices that we've got. And these there's more, we'll be doing some more work, but you've got different enunciators, control stations. So this just gives you a real good handle on what your job looks like. Some of this stuff can be used for, you can do your detailed reports for your MCC, what kind of ASD you're getting, circuit breakers, disconnect switches, and stuff like that. So you've seen some of this in other videos, but really one of the real unique features of this software is the ability to do all these other types of cabling. Your control cables, your low voltage cables that don't relate to power, your signal cables, your communication cables, and I'll show you how to put them in conduits. And it's just in its sizes. If you will be able to combine conduits, so some cables you'll have more than one cable in a conduit, and we'll go through all that. But the capability is that you should be able to completely describe your job with the project you're creating, both power, controls, cables, conduits, cable trays. And then once you have that in there, you can get it out in any number of ways to be helpful for bidding or construction or testing or anything like that. So that covers importing controls. The next video I'm going to do is conduits, and then we'll look at the 3-line capability, the utility capability to quickly add lengths for cables, stuff like that. So looking forward to it. Appreciate your time. Sorry it took so long, but as you can see, there is just a bunch to it. So have a good day, and we'll see you again soon.